I was thinking about this the other day. If a high-pressure water main just suddenly ruptures in the ceiling of a corporate headquarters, there's an immediate chain of events, right?
Oh, yeah. Chaos.
Mhm.
Absolute chaos.
Right. I mean, water destroys the drop ceiling, the drywall starts to bow under the weight, and within I don't know, minutes, employees are literally dodging active waterfalls just trying to get to the elevator.
Yeah, you can't ignore that.
Mhm.
Every single person in the building notices it immediately.
Exactly. And facilities, they shut off the main valve before the hour is out because visible physical damage provokes this really visceral, immediate response. You see the leak, you stop the leak.
Well, yeah, it forces a reaction because the physical world just doesn't tolerate ignored physics. I mean, you don't convene a quarterly steering committee to discuss a flooded lobby. You just cut the flow.
Right, you just act. But then, and this is what we're getting into today, you transition into the realm of digital infrastructure. You step into the architecture of modern corporate software and cloud deployments, and suddenly that bursting pipe is completely silent.
Totally silent. Invisible, even.
There's no water pooling on the floor. There's no sagging drywall. Instead, you just have this massive, invisible, high-pressure leak pouring hundreds of millions of dollars into the void every single year, and nobody's calling facilities.
No, because they can't see it. The hazard is entirely unmanaged because it's abstracted away from the people who are actually paying the bills.
We are looking at a financial and operational landscape that is just bleeding out in the dark, and most executives, honestly, they don't even realize the valve is broken.
They really don't. And, I mean, the leak isn't a bug in the system. It is the fundamental architecture of how modern enterprises procure and provision technology today. The friction that used to prevent waste, it's been entirely engineered out of the process.
It really has. So, welcome to this deep dive. Today, we are going straight into the belly of that digital beast. We're talking decentralized software bloat, the massive scale of cloud waste, and the really pervasive crisis of shadow AI.
Yeah, this is a big one.
It is. And for you listening right now, think of this less like a standard technology overview and more like a high-stakes financial rescue operation. We're going to explore exactly how to engineer a systemic structural intervention known as a correlation engine.
Right, and the foundational philosophy for this approach, which we're definitely going to unpack in detail, it's rooted in this fascinating set of operational engineering blueprints from a source titled The Quiet Architect.
Such a great source.
It really is. It treats technology not merely as a vector for growth, but as a mechanism for what they call restorative engineering.
Yeah.
And to back that up, we are also heavily analyzing the financial data from Xylo's 2026 SaaS Management Index, along with some really eye-opening cloud infrastructure telemetry from the analysts at Wie.
Yeah, those numbers are wild. So here is the core promise for you today. Organizations are bleeding massive amounts of capital due to this profound blind spot between what their ledgers say they pay for and what their telemetry says they actually use.
The gap between the invoice and reality.
Exactly.
Yeah.
So by the end of this conversation, you will have a highly technical, step-by-step roadmap to implement this correlation system. A system that cuts ghost subscriptions, isolates unvetted shadow AI, and most importantly, proves undeniable hard dollar ROI to your executive stakeholder.
That's the holy grail, right? Proving the ROI.
Oh, 100%. So let's start with the sheer volume of water leaking from this digital pipe. I mean, the scale of the problem in cloud infrastructure alone is staggering.
It really is. I mean, if we look at the raw infrastructure layer first, the compute, the storage, the networking, the numbers from the March 2026 Wie reporting indicate that cloud waste is at 29%.
29%.
And frankly, that is the conservative baseline drawn from Flexera. If you look at Stormforge's survey of infrastructure professionals, they reveal an average waste closer to 47% of total cloud budgets.
47%. That is almost half. So of the projected $840 billion in global cloud spending for 2026, we are talking about roughly $240 billion that just vanishes.
As it evaporates.
I want to dig into the mechanics of that. I mean, how does an organization accidentally waste half of its cloud budget? What does an idle resource actually look like in practice?
Well, it takes a lot of forms, but the most common is probably the over-provisioned compute instance. So imagine a development team needs to run a load testing simulation.
Okay. Pretty standard.
Yeah. They write an infrastructure as code script to spin up this massive Kubernetes cluster with dozens of high-memory nodes. They run the test on a Friday afternoon. The test completes, but the teardown script fails. Or maybe it was just never written.
Oh, no. So they just leave for the weekend.
Exactly. The engineers go home. And that cluster just sits there, idle, spinning CPU cycles on background operating system tasks, racking up thousands of dollars a day.
Just burning cash while no one is even looking at it.
Right. Or consider block storage volumes attached to virtual machines that were terminated weeks ago. The compute is gone, but the data volume is still sitting there unattached, billing by the gigabyte every single month.
Wow. Because the friction to create the resource is basically zero, but the friction to track and destroy it requires active governance.
Precisely.
But that's the heavy infrastructure side, right? What happens when we move up the stack to the software side, like the SaaS applications that end users are interacting with daily?
Well, the SaaS environment is arguably more insidious because it bypasses centralized IT entirely. Zyla's index shows the average organization wastes $17 million annually on unused software.
17 million, just on unused software.
Yeah. And for large enterprises like exceeding 10,000 employees, they spend over $224 million annually on SaaS, yet physically utilize only 50% of the provision licenses.
50%. Okay, let's apply our physical world logic to that for a second. If a procurement team bought 10,000 high-end ergonomic desk chairs, right, and 5,000 of them were just left wrapped in plastic sitting in a rented warehouse for 3 years, there would be a massive internal audit.
Oh, people would definitely lose their jobs over that.
Exactly, but because a SaaS license is just, a JSON payload and a line item on a ledger, it completely escapes scrutiny.
It does. And the root cause of that 50% utilization rate is really the democratization of purchasing. The shift to cloud-delivered applications completely removed the physical installation barrier.
Right, you don't need CD-ROMs anymore.
No, an employee no longer needs an IT administrator with admin privileges to install a binary file on their machine. They just open a web browser. But that operational freedom completely destroyed the traditional procurement gateway.
It totally did. I mean, the sources point out that 1 in 6 employees is now actively expensing SaaS applications directly on their corporate credit cards. They are completely bypassing the information technology department.
1 in 6. And as a result, the average enterprise is adding 6 entirely new applications to its technology stack every single month.
6 new apps every month. That's crazy.
And these are tools entering the corporate ecosystem without security vetting, without compliance checks for data residency, and without any overarching strategic architectural review. It is purely decentralized, ad hoc consumption.
And this brings us to a massive accelerant detailed in the sources. The ChatGPT effect.
Oh, yeah, the shadow AI crisis.
Right, because we've always had shadow IT,
Right.
someone buying a random project management tool or a niche design app. But the integration of generative AI into the daily workflow has completely warped the scale of this problem.
It really has. The pressure on the modern workforce to accelerate output is just immense right now, and generative AI is the lever they are reaching for. But they aren't waiting for enterprise-grade SOC 2 compliant AI rollouts from their internal teams.
No, they're impatient. They want it now.
Exactly. They are independently expensing consumer-tier AI subscriptions outside of corporate purview. The data shows AI-native application spend within the enterprise context has grown by 393% year over year.
Wow, 393%.
Yeah.
And the typical subscriber isn't just using one tool, right? They are utilizing 4 paid AI tools simultaneously, pushing the company's cost to about $66 per month per subscriber on just these shadow expenses.
Yeah, it adds up incredibly fast. AI chatbots are now the 11th most frequently used shadow application in corporate environments.
But here is what I really want to understand. Why is integrating and managing AI subscription billing so much more difficult than tracking standard SaaS? What is it about AI that breaks our traditional financial models?
Well, the difficulty stems from a fundamental divergence in pricing architectures. Traditional SaaS utilizes a fixed-seat license model.
Okay, so like paying per user.
Right. You provision a user and you pay a static fee, say $50 a month, regardless of whether that user logs in once or 1,000 times. The financial liability is capped.
Makes sense.
But AI costs, they scale unpredictably based on consumption metrics, specifically token usage and compute cycles for inference.
So the financial liability is uncapped. It's not a subscription. It's more like a utility meter running in the background.
That's a perfect way to put it.
Walk me through how that actually spirals out of control on a technical level.
Okay, let's take a really common scenario. Say a mid-level engineering team decides to experiment with an API for a large language model to automate some data parsing. They aren't using a fixed-price chat interface. They are hitting the raw API. Now, with LLMs, you are billed on both input and output tokens. When you build an autonomous agent, or say, a recursive loop that continuously feeds context windows back into the model to refine a task, the token count grows exponentially.
Oh man, I can see where this is going.
Yeah. A single poorly optimized script can loop over a weekend and generate tens of thousands of dollars in token charges before an anomaly detection alert ever even fires in the finance department.
Because every time the loop runs, it's not just sending the new prompt, it's resending the entire context history, right? The payload gets heavier and more expensive with every single API call.
Precisely that mechanism. And furthermore, organizations are over-provisioning highly expensive GPU instances for training their own internal models. They reserve a block of A100 GPUs, run their training epoch, and then they fail to optimize their inference workloads, or they simply leave the instances running idle.
So AI billing creates these highly variable, deeply obscured patterns of waste because the cost is completely decoupled from the headcount.
Exactly.
To put the sheer chaos of this into perspective, let's go back to an architectural metaphor. The 50% sauce utilization rate we talked about. It's like procurement securing a massive volume discount on a 1,000-car parking garage, only to realize that 500 employees work fully remote and never even drive to the office.
It's spot on.
And then the shadow AI crisis is a sixth of your remaining staff using corporate cards to rent daily premium valet parking spots in a completely different garage across the street just because they like the service better.
Yep.
And meanwhile, the cloud waste is just leaving the engines running on a fleet of company buses 24/7 just in case someone needs a ride.
It's a great analogy. It really highlights the absurdity of it.
But if the waste is this numerically obvious, why do 70% of these software contracts blindly auto-renew every single year? Like, who is asleep at the wheel here?
Well, the failure isn't a lack of attention, really. It's a structural bottleneck in corporate architecture. The modern enterprise relies on three distinct nodes that operate in almost total isolation.
Okay, who are they?
You have procurement, which negotiates the initial contract and secures the volume pricing tiers. You have finance, which processes the accounts payable and clears the monthly invoices. And you have IT, which manages the identity provider and provisions the access.
3 separate silos. And I'm guessing none of their APIs are talking to each other.
They do not dynamically communicate at all. Consider the life cycle of a software renewal. Finance sees a recurring invoice on the ledger, and they just assume the tool is actively required for business operations.
Right, because why else would they be paying for it?
Exactly. Meanwhile, IT provisions the single sign-on account, but they rarely audit if the user maintains active sessions months later. And procurement. They rely on a static spreadsheet reviewed annually. They look at the sheet, see that finance is paying the bill, and IT hasn't flagged any security issues, and they just authorize the auto renewal.
Wow. So the entire governance system relies on static, disconnected ledgers trying to track highly dynamic, unpredictable human behavior.
That's exactly the bottleneck.
Which brings us to the core technical intervention of this deep dive. We've mapped the financial bleed, the $240 billion in cloud, the $17 million in sauce waste. We've identified the structural bottleneck of these isolated departments. So how do we engineer a systemic fix?
Right.
The solution detailed in the Quiet Architect blueprints is fascinating because of what it explicitly forbids. It warns against building a massive monolithic integration suite. It says, do not embark on a multi-year digital transformation project to fix this.
Yeah, that's a trap a lot of companies fall into.
Instead, you capture the ultimate control point using what they call a correlation engine.
Yes, the correlation engine. The Quiet Architect framework is heavily focused on what it terms restorative engineering.
I love that term.
Me too. Because the goal isn't to add more complex software to manage your existing complex software.
Yeah.
That just adds to the bloat.
Right.
The goal is to deploy a lightweight API architecture whose sole function is to strictly correlate data between two existing definitive corporate sources, the single sign-on identity provider and the expense management ledger.
Okay, so I want to break this down into a really highly technical step-by-step guide for implementing this correlation engine. Because we need to understand how to actually build this. Step 1 is identifying those definitive sources of truth, right? Focus on matching SSO login data with expense ledgers.
Exactly. You are capturing two distinct events. First, the operational event. Your single sign-on telemetry systems like Okta, Microsoft Entra, or Ping Identity.
Okay.
This is your undisputed operational record. It logs exactly who authenticates to which specific application identifier and the exact timestamp of that authentication.
So that is the digital heartbeat. If the identity provider has no record of a session token being issued, the employee did not use the software, period.
Exactly. You can't fake the login. The second source is the financial event. The expense ledger platforms like Expensify, Concur, or even the direct corporate credit card transaction API.
Right, where the money actually moves.
Yep. This system maintains the immutable record of who initiated the purchase, the vendor entity, the transaction amount, and the billing cycle.
Okay, so that's step one. We have our two sources. Step two is the actual engineering challenge. We have to detail the API data schema required to map login timestamps to billing cycles.
This is where it gets tricky.
Yeah, because we have to build the mapping logic to bridge these two completely isolated databases. How does this script actually normalize and map a login timestamp to a billing cycle? Because the data structures between Okta and Expensify are completely different.
Right, they don't natively speak the same language. The API data schema requires a really robust normalization pipeline. The engine initiates a GDT request to the SSO API to pull a stream of operational metadata.
What exactly is it looking for in that payload?
The critical piece of data you're extracting is the last login timestamp. This needs to be standardized, typically into ISO 80601 format, so you can actually do time-based comparisons, and it must be mapped to a unique internal user ID and a standardized application ID.
Okay, so we end up with a normalized record, something like user ID 4092 authenticated to application ID Salesforce on 2026-1014T09.02.00Z.
Perfect, yes. Concurrently, the engine pulls the financial metadata via the expense management API. This JSON payload contains the purchaser ID, the raw merchant string, the transaction amount, and the transaction date.
Got it.
And here is the heavy lifting for the correlation engine. The string matching and normalization phase, you are attempting to connect a messy credit card merchant string like SFDCS sub 8881283 to the clean Salesforce application ID in your operational database.
Wait, I really want to drill into that string matching. With Shadow IT, vendor names on credit card statements are notoriously cryptic.
Oh, they are awful.
Right, like a ChatGPT subscription might show up as OpenA San Francisco or just Stripe EA tool. How does the engine accurately map that without a human sitting there manually tagging thousands of rows of transactions?
It utilizes sophisticated string matching algorithms. Specifically, it's calculating the Levenstein distance to account for typos or abbreviations, and it combines that with tokenization of the strings.
Okay, that sounds intense.
It is, but more importantly, it leverages merchant category codes, or MCCs, and historical transaction mapping databases.
So how does that look in practice?
When the engine encounters OpenAI sub, it strips the special characters, tokenizes OpenAI, cross-references it against a known dictionary of SaaS vendor domains, and assigns a confidence score to the match.
Ah, okay.
If the confidence score exceeds a set threshold, it creates the mapping, binding the financial identity to the SSO application ID.
That makes total sense. So once that mapping is established and we have clean data, we apply the critical logic loop, the 60-day lag rule.
Yes, the 60-day lag rule. The engine continuously compares the normalized login timestamps against the billing cycles. The script is programmed to instantly flag any application license that registers a cleared financial invoice in the current billing cycle, but possesses a last login timestamp older than 60 days.
Which brings us to step 3 of the implementation guide. The distinction between an invoice and a login. The Quiet Architect blueprints establish a first principle rule here, and I love this quote. A cleared invoice is a financial event. A validated login is an operational event. Trust only the operational event.
That is the absolute fulcrum of restorative engineering. Spend does not equate to adoption.
Exactly.
An invoice only tells you what procurement thinks you have. The SSO telemetry tells you what operational reality actually is.
Right. But I want to challenge this setup with the hardest part of the puzzle we discussed earlier, the shadow AI crisis. Describe the technical challenges when integrating disparate AI subscription billing across cloud platforms, and analyze how to track and terminate unvetted AI subscriptions purchased via corporate credit cards.
Yeah, this is the real test of the system.
If an employee uses their corporate card to buy a rogue generative AI tool, they bypassed IT. That tool is not provisioned in Okta. The SSO provider literally doesn't know it exists. So how can we correlate a login timestamp if the app isn't even in the identity directory?
That exact scenario demonstrates why the cross-referencing architecture is so powerful. Let's trace the data flow of that shadow AI purchase.
Okay, let's trace it.
The employee subscribes to the rogue AI tool. Because it's not in the SSO directory, the operational database has no record of it. However, to get reimbursed, that employee must submit the expense report, or the charge hits the corporate card ledger directly.
Right. The financial event still occurs. They want their money back.
Exactly.
Yeah.
And the correlation engine is constantly polling that expense ledger API. It ingests the new transaction, normalizes the vendor string, identifies it as an AI application, and extracts the purchaser's ID.
Right.
The engine then queries the SSO API. Show me all active application sessions for this user ID relating to this vendor.
And the SSO API returns a null result.
The null result is the trigger.
Wow.
The correlation engine flags an immediate critical discrepancy. It alerts the FinOps team that finance is actively paying for a software tool that possesses zero operational footprint within the company's secure identity boundary.
That is so smart. The financial data exposes the existence of the tool, and the lack of operational data proves it is unvetted and operating outside of governance.
Exactly. It uses the void in the data to prove the shadow IT exists. Once that alert fires, IT can either terminate the subscription to stop the financial leak, or if the AI tool is actually driving productivity, they can pull it out of the shadows.
Right. They can officially sanction it.
They can provision it via SSO, enforce multi-factor authentication, and negotiate an enterprise contract instead of paying retail credit card prices. It forces visibility upon the invisible.
It really does. But having the engine and having the data is only half the battle. If I plug this correlation scripts into my enterprise environment tomorrow and it suddenly flags 400 shadow applications and 10,000 unused licenses, I can't just let an automated script start revoking access and canceling corporate cards on day one. That would paralyze the company.
Oh, absolutely. Deploying automation without contextual mapping is reckless. You'd break half the business.
So how do we actually roll this out safely?
The Quiet Architect source material explicitly outlines a phased 90-day roadmap for deploying the engine and the initial audit. It is strictly designed to introduce total visibility before it enforces any control mechanisms.
Okay, let's walk through that roadmap. If we look at month 1, the initial audit, the engine is deployed in a purely passive read-only state, right?
Yes. In month 1, the script only monitors the APIs. It ingests data, normalizes strings, and builds the correlation maps, but it does not execute any delete or revoke commands whatsoever.
It's just watching.
Exactly. It conducts a comprehensive SOS audit. It identifies every instance of shadow IT, lists every provision tool alongside the users attached to them, and calculates the exact financial waste down to the dollar based on that 60-day lag rule.
So it establishes the baseline. You map the entire blast radius of the waste before you touch anything.
Right.
But imagine running this across an enterprise of, say, 10,000 employees, pulling all that historical data that generates massive API load. How do you handle rate limiting from Okta or Expensify during this initial audit phase?
That's a critical engineering detail. The engine must be designed with robust pagination and back-off algorithms. You cannot query 10,000 user records simultaneously. You'll get blocked instantly.
Right, you'll DDoS your own identity provider.
Yeah, exactly. So the script pulls the data in chunked requests during off-peak operational hours. It caches the responses in a localized secure database and performs the correlation analysis asynchronously. You have to respect the API rate limits to ensure you don't degrade the performance of the actual systems.
Makes total sense. So once that baseline is established, mapped, and presented to leadership, we move to month 2. Consolidation and severing. This is the active intervention phase.
Yes. Month 2 is where the theoretical savings become actual recovered capital.
Yeah.
The enterprise uses the correlated data to take decisive action. And the first step is application rationalization.
What does that look like?
The engine's dashboard will clearly visualize redundancies. It will show you that marketing expenses Asana, engineering uses Jira, sales uses Monday.com, and operations relies on Trello.
Oh, I've seen that exact scenario so many times.
Right. The organization is paying 4 different vendors to solve the exact same project management problem.
But here's the thing. Application rationalization always sounds great in a boardroom, but in practice, taking away a team's preferred tool is highly political. Sales will argue that Monday.com is absolutely critical to their specific workflow. How does the FinOps team win that argument?
They win it with the correlation data. The FinOps team doesn't just say, we are cutting your tool. They say, our SSO telemetry shows that out of the 200 licenses we pay for on Monday.com, only 40 users have initiated an active session in the last 60 days.
Oh, wow. You just bring the receipts.
Exactly. You say, the data proves the tool is not systemically adopted by your team. The data removes the emotional attachment and frames it purely as an objective resource allocation issue. You force consolidation onto a single enterprise-negotiated platform.
That is so hard to argue against.
It is. And concurrently, the engine executes the severing phase. It actively targets the waste identified by the lag rule. It revokes SSO access for users who haven't authenticated in 60 days and triggers automated API calls to the vendor to downgrade the license count.
So surgical and automatic, which naturally leads us to month 3, governance and alerts. You've cleaned the house, but you have to build systems to ensure the bloat doesn't slowly creep back in over the next fiscal year.
Exactly. Month 3 transitions the system from a cleanup operation to permanent operational guardrails. The most vital component here is automated contract alerting.
How does that work?
Because the engine is continuously mapping financial billing cycles, it monitors the specific notice periods required to cancel a software contract, which is often 30 to 90 days before the renewal date.
Okay, so it knows the deadlines.
Yes. The system routes automated alerts to the procurement team well before that window closes, summarizing the actual SSO utilization of that platform.
That is brilliant. It fundamentally shifts the organization from a reactive posture, where finance just blindly pays the auto-renewing invoice, to a proactive posture where every renewal is justified by undeniable operational data.
It's a complete paradigm shift.
But I want to pivot to the ultimate hurdle for any engineering or FinOps team trying to implement this framework. We need to explain how this technical approach helps FinOps teams prove business value to executives, translating these technical cost savings into clear ROI metrics for executive stakeholders.
Right, because if you can't sell it to the CFO, it doesn't matter how elegant the code is.
Exactly. So to effectively pitch this to executive stakeholders, you must first understand the default failure mode of corporate cost-cutting, right?
Yes. When macroeconomic pressures rise or revenue targets are missed, a CFO lacking this granular visibility will typically mandate what we call the hammer approach.
The dreaded top-down memo. Every department is mandated to reduce software expenditure by a flat 10% by the end of Q3.
The hammer approach is deeply destructive because it is completely blind. A department manager forced to meet an arbitrary 10% reduction will often cut mission-critical specialized tools or delay necessary infrastructure upgrades.
Because they have to cut somewhere.
Exactly. But meanwhile, because they lack visibility into the decentralized shadow IT, the invisible zombie subscriptions, the unused licenses that make up the actual bloat, they remain completely untouched. The organization amputates healthy muscle while leaving the fat intact.
Because the CFO is looking at a high-level spreadsheet, they see that the total Adobe bill is, I don't know, $2 million. They don't know that 80% of those licenses haven't been used in 3 months, so they just demand a raw budget cut. How does the correlation engine change that boardroom dynamic?
It replaces the blunt hammer with a surgical scalpel. When you present the ROI of a correlation engine, you aren't pitching a theoretical efficiency gain. You are presenting localized, verifiable capital recovery.
Give me some numbers. What does the data say?
The source data confirms that organizations implementing structured FinOps programs achieve a 25 to 30% cost reduction within the first 3 to 6 months of deployment.
A 30% reduction without breaking a single active workflow, because you are only cutting what the operational data proves is already dead.
Exactly. And the case studies in the Baidiota reporting provide massive validation for this. The numbers are just staggering when applied at enterprise scale.
Give me an example.
Okay, an insurance company utilized these exact correlation practices to cut $100 million annually from a single application environment.
Let's pause on that. $100 million from one application. How is that even structurally possible?
It occurs in massive enterprise licensing agreements. The company likely negotiated an all-encompassing site license for a premium suite of tools based on projected headcount growth.
Oh, I see. They bought for what they thought they'd need.
Right, and the correlation engine revealed that vast swaths of the workforce only required basic read access, not the premium authoring tiers they were provisioned for. By systematically downgrading licenses based on actual feature utilization mapped via telemetry, the savings scale massively.
That is incredible.
Another Azure enterprise documented a $22 million savings, representing a 36% reduction in their total infrastructure cost, purely by right-sizing instances and killing orphan storage volumes. MakeMyTrip reduced their compute costs by 22% through the same systematic optimization.
This transitions perfectly into a highly lucrative startup and consulting model detailed in the text. The shared savings monetization arbitrage. If I'm an internal FinOps director or an external consultant pitching this correlation engine to leadership, this pricing model is the ultimate executive hook.
It really is. It resolves the paradox of selling cost optimization software. Historically, if you try to sell a SaaS management platform to a CFO, you're asking them to add a new, expensive software subscription to the very budget they are desperately trying to shrink.
Spend money to save money. It's a tough sell.
Exactly. But the shared savings model bypasses this entirely. The operator deploys the correlation engine and bills the client a fraction of the verified localized savings extracted directly from the canceled subscriptions.
You prove the waste, you execute the cancellation, and your fee is a percentage of the recovered capital. For example, saving the enterprise 4% of their total SaaS costs in the first quarter, scaling to a 16% savings within the first year?
Right. The fee for the correlation service is fully subsidized by the eliminated waste. It represents a net zero new budget request for the CFO.
That is such an easy pitch. But I have to push back on the incentives there. If a FinOps team or a third-party startup is purely compensated on the volume of software they cancel, doesn't that create a perverse incentive? What stops them from aggressively cutting tools that teams actually need just to boost their own commission payout?
That is precisely why the correlation engine is anchored to the operational event, not just the financial event. The operator cannot claim savings based on arbitrary cuts. The severed licenses must be verified against the SSO telemetry.
Ah, so there's a built-in check.
Yes. If a license registers active logins, the engine prevents it from being flagged for termination. The savings must be forensically proven to be derived from zero utilization assets. The data acts as the neutral arbiter, preventing overzealous cutting.
The telemetry keeps the system honest. I love that. Okay, let's look further down the timeline. We've executed the 90-day audit. We've consolidated the tech stack. We've proven the ROI to the CFO. But human behavior is resilient. People will eventually try to find a workaround. How do we establish permanent corporate governance policies regarding software procurement and usage?
Effective FinOps must evolve from a discrete audit into a continuous embedded discipline. Permanent governance requires integrating cost awareness directly into the daily provisioning workflows.
What does that actually look like for an engineer?
It mandates strict automated tagging policies at the point of creation. If an engineer attempts to spin up a cloud instance without applying a metadata tag defining the project owner, the environment, and the specific cost center, the CI/CD pipeline automatically rejects the deployment.
Wow. No tag, no compute. You enforce financial accountability at the infrastructure as code layer.
Exactly. Furthermore, it requires establishing automated license reclamation as a permanent, silent background process. The 60-day lag rule isn't just run once a quarter, it runs continuously.
It's always watching.
Yes. If a user trips the threshold, the system automatically revokes the license and triggers a webhook to a Slack bot, asking the user's manager if the provisioning is still required.
Okay, so digital policies and API correlations are highly effective for entirely digital environments. But what about hybrid operational spaces? What about environments where digital software interacts directly with physical reality? I'm thinking of industrial manufacturing floors, logistics hubs, or hospital wards. The Quiet Architect blueprints propose a fascinating and honestly somewhat radical solution for this specific gap.
Yeah, this part of the blueprint is amazing. They detail a project termed the Sentinel node. The limitation of an API correlation engine is that it only sees what the cloud providers tell it. In an industrial environment, the software usage is deeply tethered to physical presence.
Right.
So the Sentinel node takes the logic of the correlation engine and deploys it physically. It is an edge-computed network appliance installed directly into the network racks on the factory floor.
So it's a literal piece of hardware,
Right.
like a one-use server sitting in a telecom closet. What is it actually doing?
It acts as the ultimate bridge between physical reality and digital bloat. The mechanism operates at the network layer. The appliance passively monitors MAC addresses and active network packet traffic, specifically analyzing Layer 7 application data bound for high-cost, specialized SaaS IP ranges.
Wait, so it's sniffing the actual packets leaving the local network and heading to the software vendor's servers.
Correct. And here is where the multi-layered correlation occurs. The appliance cross-references this physical network packet traffic with two other definitive databases: the Human Resources Shift Scheduling API and the SSO Identity Provider.
Okay, walk me through a concrete scenario of how this actually executes.
Imagine a heavy manufacturing facility. The company pays for a highly expensive manufacturing execution system, or MES, software license for a specialized machine operator on the third shift.
Okay, pretty common.
The HR API confirms the worker is currently clocked in. The SSO provider confirms their account is active. However, the Sentinel node appliance, which is monitoring the local switch, detects absolutely zero network packet traffic originating from that workstation bound for the MES SaaS endpoint during the entirety of their physical shift.
So the worker is physically present, the license is paid for, but the network telemetry proves the software is never actually interacting with the network while they are working.
Exactly. The correlation engine identifies the anomaly. If the network appliance detects zero traffic during the shift, it automatically flags that premium license for termination. The correlation proves the tool, despite being provisioned and paid for, is completely ignored on the factory floor.
I have to challenge this approach. Implementing packet-sniffing hardware that cross-references HR schedules to instantly cancel software access, that sounds incredibly strict, bordering on, like, dystopian surveillance. What if the operator was in a mandatory safety training all day? What if they were performing physical, off-network maintenance on the machine? Are we just instantly firing their software access and breaking their workflow for the next day?
It is a vital concern, and if implemented poorly, it could certainly become adversarial. But this is where understanding the core philosophy of restorative engineering anchors the entire deployment.
How so?
The objective of the Sentinel node isn't to punish the worker, nor is it to establish a surveillance state to track productivity. The objective is strictly to identify and remove abstract, invisible financial waste so that organizational resources can be reallocated to physical utility.
Expand on that distinction for me. How does canceling their software improve their physical utility?
Well, if the expensive software tool isn't generating network traffic during the shift, whether it's because the worker is legitimately engaged in physical maintenance or simply because the software interface is poorly designed and the workers bypass it, that digital license is a leak. It is a broken digital abstraction.
Right.
By utilizing the Sentinel node to automatically reclaim that cost, the capital is freed. Instead of paying for a ghost digital license that provides no operational value, that exact capital can be redirected. It can be invested in upgrading physical safety equipment on the floor, purchasing better physical tools, or directly funding wage increases. You are systematically removing a failed digital abstraction to restore tangible physical capability to the organization.
Wow, that entirely reframes the dynamic. It isn't about taking a necessary tool away from a worker, it's about refusing to pay for an illusion. If the software isn't generating packets, it isn't generating value. You cut the digital ghost to fund the physical reality. And if we zoom out, that philosophical shift really encapsulates the entire journey we've taken today.
It is a comprehensive reimagining of technology management. We have covered a massive amount of highly technical ground today.
We really have. Just to summarize the architecture we've built for you today, you now understand the staggering volume of the problem, the 240 billion evaporating in cloud waste, the 17 million in standard SaaS leaks per enterprise, heavily accelerated by the unpredictable token billing of the shadow AI crisis.
It's a huge problem.
Huge. We walked step by step through the specific API schema required to build a correlation engine, normalizing and matching operational SSO login timestamps with financial expense ledgers using the 60-day lag rule. We laid out the precise 90-day roadmap to passively audit, actively consolidate, and permanently govern your technology stack without breaking active workflows.
That roadmap is key.
And we detailed how to translate that forensic data into a shared savings ROI pitch that replaces the CFO's blind hammer with a scalpel, leading all the way to the physical governance of the Sentinel node.
It is a definitive blueprint for reclaiming operational sanity in an era of infinite digital sprawl. And I believe we should leave you with a final philosophical point drawn from the Quiet Architect.
Let's hear it.
We have been conditioned to view technology primarily as a force to disrupt markets, to accelerate past our competitors, or to, move fast and break things. But the highest, most mature form of engineering is restorative.
Restorative engineering.
Yes, by actively severing invisible digital waste, by ruthlessly cutting software bloat, and by engineering correlation systems that enforce operational truth, you aren't simply optimizing a spreadsheet to save money. You are restoring order, you are restoring intent, and you are restoring true capability to your organization. You are forcing the system to become honest again.
Forcing the system to become honest. That is a powerful mandate. So I want to turn this directly to you, listening right now. Take a hard look at your own corporate ledgers today. Think about the decentralized tools your team expensed this month. Think about the idle cloud instances spinning quietly in the background over the weekend.
Yeah, what's hiding in there?
Exactly. Are you paying for the illusion of technological control, or are you actually managing your operational reality? What invisible zombie subscriptions is your own obscurity keeping alive right now, silently draining capital into the void?
It is the most critical question an operational leader can ask themselves today.
It truly is. Thank you for joining us on this deep dive. We hope this roadmap equips you to find those hidden leaks and finally shut off the water. Keep questioning the baseline, demand operational truth, and we'll catch you on the next one.